Now, one last thing I want to say about asteroids before I move on to another type of object. And that is, what substance did we say asteroids can't have in them? I said they could have rock. I said they can have metal. What can they not have? What can asteroids not have? Ice, right? And there's got to be a reason that they can't have ice, right? There's got to be a reason they can't have ice. And it turns out the reason they can't have ice is actually very, very simple. Let's think about this. Don't even worry about asteroids or space right now. What is a typical, simple situation? Here we go, Florida. Why is it hard for Florida to have a bunch of ice? Why don't we just have a whole ton of ice outside here in Florida? Why is there no ice just sitting around in Florida? Yeah, it's too hot, right? It's too hot. So why can't asteroids have ice? Because it's too hot where they are. It's at least too warm, okay? Now, what is making it too warm here in the asteroid belt? What's making it too warm right here for ice? Don't overthink this. There's a big old source of heat, right? There's a big old source of heat somewhere here. The sun. The sun. Yes, it's the sun. So essentially, where the asteroids are in space, it's too warm in they're exposed to too much direct sunlight to form ice, okay? Now don't get confused. Earth does have ice, but our ice is at our poles, and our atmosphere situation makes it so that our ice, the natural ice, is mostly protected from the sun. But asteroids are just floating around exposed in space with no atmosphere or nothing like that. And so it's too warm here in space to have ice, okay? So, here we go. What if you took an asteroid and put it further out in the solar system? In that case, what would happen to the temperature? If you took some of these and put them further out in the solar system, what would happen to the temperature? Don't overthink this. It would get colder, right? So if you took some of these asteroids and put them far enough out, you could have ice mixed in with that rock and metal. And if you did go far enough out that rock and metal starts to mix, if you go far enough out that rock and metal starts to mix with ice, you'd have something that looks basically the same as an asteroid. And in my opinion, it basically is just an asteroid with ice mixed in. But if it does have ice mixed in, it has a different name, okay? If they're far enough out to have ice mixed in, instead of calling it an asteroid, we call it a trans-Neptunian object. Trans-Neptunian object, okay? So, trans-Neptunian objects are just like asteroids, but instead of being made of just rock and metal, they're made out of rock, metal, and ice, okay? And like we just said, where do they exist? They exist farther out in the solar system than the asteroid belt. So let me zoom out a little bit. It turns out that the trans-Neptunian objects actually fall in two different places, okay? They fall in two different places. And one of them is another belt out here. So let me just draw a belt around the outer edge. There we go. And it would make sense to call that the trans-Neptunian object belt. But we actually named this after a person. So that belt is actually called the Kuiper Belt. Kuiper Belt. Let me zoom in on that real quick. There we go. It kind of looks like Kuiper Belt, but the U is silent. It's the Kuiper Belt. So the asteroid belt is full of asteroids, and the Kuiper Belt is full of trans-Neptunian objects. Okay? The asteroid belt is full of asteroids, and the Kuiper Belt is full of trans-Neptunian objects. But basically, other than this outer belt having ice, they're basically very similar. Okay? They're basically very similar. Everything in here, there's millions and millions of objects in the Kuiper Belt, but they all orbit around the sun like tiny little planets. Okay? And they can be big, and some of them are big enough to be round. There's thousands of them big enough to be round. Smaller ones are more misshapen. Everything we said about asteroids is basically also true for these, except for they have ice. Okay? And there's one other place where you find trans-Neptunian objects that I'm not going to draw on here because it's way too far out from the rest of the solar system. Now, here's something important. Everything that I've drawn so far is basically flat in terms of their orbits. All these orbits are going the same direction, and they're in the same plane. So if I took this, right, and turned it on its side, all of this would be flat. That's why they're called belts, because they're sort of a ring around the sun, right? They're belt-shaped. But all of the orbits of the planets and both of those belts, that's shaped like a frisbee, okay? But if you go even farther out, way farther out, eventually you're going to find another region of trans-Neptunian objects called, and I'll write it over here, the Oort Cloud. That's O-O-R-T, the Oort Cloud. And it's full of the same kind of objects as the Kuiper Belt, but it's twice as wide, so it's way out here, and it's not flat, okay? It's not flat. Everything in the belts goes the same direction as the planets, but in the Oort Cloud, every direction is possible. Everything in the Oort Cloud orbits in random directions. So some things orbit the same direction as the planets, but some things go vertical, some things go diagonal, some things go backwards. And because anytime you have random orbits, if you truly have fully random orbits, you're going to end up with a big ball of material, okay? So imagine that everything we drew was like a frisbee. And let's say you took that frisbee and put it directly in the center of a giant beach ball, okay? That beach ball would be the Oort Cloud, and everything we drew would be the frisbee in the center, okay? Now, here's the thing. Here's the thing. Here we go. Let's talk about this. Let's talk about this. What did we discover first? What did we discover first? The asteroid belt, the Kuiper Belt, or the Oort Cloud? Which one did we probably discover first? If you were to take a guess. The asteroid belt. The asteroid belt. So we discovered the asteroid belt before the Kuiper Belt. Don't overthink this. Why did we discover the asteroid belt first? Don't overthink this. Why did we know about this one before we knew about this one? Yeah, it's just closer to us, right? It's just closer to us. So we discovered the asteroid belt a long time ago, right? A long time ago. The Kuiper Belt was only discovered about 100 years ago. And the Oort Cloud after that. So by the time we found the Kuiper Belt, we had already found millions of asteroids. Okay, we already knew about millions of asteroids by the time we found the Kuiper Belt. And when we first found the Kuiper Belt, what are all of our pictures of the Kuiper Belt going to be like? Well, they're going to turn out blurry. Because the Kuiper Belt is farther away, all the pictures we have of it are blurry. Let me show you a picture of some of the objects in the Kuiper Belt. So here we go. Here's a picture from your book. Where did it go? Where did it go? There we go. Here's a picture of some Kuiper Belt objects, some trans-Neptunian objects from the Kuiper Belt. If we could zoom in on these things, they look basically like this.